In our final case study for the day, we will be looking at infrastructure innovation. Engineer Dhammika Deshapriya Silva, General Manager and Head of Structural Designs at Access Engineering PLC, will discuss how value engineering and local adaptations are driving down the cost of building expressways while maintaining high quality and efficiency. Please join me in welcoming Engineer Dhammika Deshapriya Silva onto the stage.
Good afternoon, everybody. Thank you very much for kind introduction. Today, my topic is value engineering through local adaptation, pathway to sustainable economic growth. First of all, I would like to thank Advocate Institute arranging this the seminar at the right time when considering the Sri Lankan context. Going forward, my presentation outline, introduction, I would like to discuss 3 case studies, how we have done the value engineering and adaptation in Sri Lankan context. And then I would like to move into the Central Expressway project, Expressway construction, CP Package 1 and CP3 1M package, and then conclusion. The process of cost saving and efficient performance while improving functionality and quality is considered as value engineering of a construction project. The value engineering is largely discussion point of the Sri Lankan context as well as globally. Because now the resources are depleting very fast way, so we need to preserve the resources for the future generation. So therefore, this value engineering as well as the green concepts come into consideration. There are many ways of performing value engineering in a project. Use of global good practices, customizing and adaptation to suit local condition is the key to reduce the cost and improve the quality in local context. In case studies, I would like to discuss more in this aspect. By embracing local knowledge and utilizing locally available materials, we can ensure that value engineering not only meets the global standard, but also deliver the solutions that are practical, sustainable, and economically viable for the project. With that note, I would like to go to my the case studies. First case studies I would like to discuss ITC Ratnadeepa project. I would like to give some overview of this project. This is the client is Welcome Hotel Lanka Private Limited and consultant is Sterling Engineering Consultancy Services Private Limited in India. The shoring and excavation and piling contractor is Access Engineering PLC. If you see this site location, this is in year 2014. This site is, in front of this site is the Golf Face Green and Golf Face Road, and the left-hand side is a Shangri-La Hotel, and the right-hand side is Galadari Hotel. Of course, we observed that in rear side, there was the KVA line underground in this area. This is very the sophisticated, I mean, kind of, we need to do construction without disturbing the surrounding. But the excavation depth here is around 13 meters. It's like a four basement excavation, 4-story basement excavation with approximately 750 meter perimeter we need to do. Compared to what we had done previously, this is kind of a big project. So the consultant and client, the proposal was to have a typical secant pile construction. In this construction, there are a lot of drawbacks. We found that there are vibration in this concept, and also the material, the wastage, and all these things are there. So then we checked what are the globally available concepts in this situation. So, and we find that there is something called diaphragm wall. And we compare the pros and cons of this, the system, two systems, secant pile against the diaphragm wall system. So we found that the noise and vibration, it's very less in the diaphragm wall, as well as the construction period, the time for the construction is also very less, and also cost is also very less. So then we discuss with the client and consultant, there are this kind of positive aspect, and whether we can do with this diaphragm wall concept for this situation. So therefore, consultant and client happily accepted our proposal and asked us to give them the more detailed analysis designs and the whole how we are performing this. And with all the details, they accepted our proposal, and we carried out this the site for the diaphragm wall construction with very less cost and without harming the environment and with the good quality. So I would like to go to a small video presentation to see how we have done this in practice. So please enjoy the video presentation.
Access Engineering has introduced the concept and execution of the diaphragm wall in the preliminary stages of preparation of subterranean structures at foundation levels in mega high-rise building projects. This internationally advocated, exciting new development has been adopted and successfully implemented in Sri Lanka just recently. The notable advantages over other available solutions can be seen. Lower cost, quicker process, no grout used to seal the water seepage, effective in all soil, either arid or with higher water table. No extra building of wall necessary. This saves material and resources. Added advantage of digging deep even as much as 50 meters. Ideal for multi-level basement stories. Method brings greater stability and verticality. This then is the future for building basements. The Bauer GB34 proceeds with amazing accuracy. Vertical trench walls are possible because of this. The magnificent Bauer GB34 is key to the success of the diaphragm wall. The very nature of the grabber bucket and its reach ensures the ability to dig vertically and maintain accuracy. Onboard computers maintain the tension so that lateral oscillation of the grabber is minimal, and this adds to the effectiveness in maintaining verticality. Notably, the rebar cage is prefabricated on site. Instead of spot welding or tying, the use of a coupler enhances workability while also saving on cost. In the dug trench segment, the rebar cage is lowered in position. Large-scale cages can be lowered using this approach. The speed at which all this multiple activity can be done is notable. Pre-mixed concrete is applied. Using the double tremie, self-compacted concrete is introduced. Soil anchoring is the final element. The clem machine is outstanding in its flexibility, even in confined space. This technologically advanced device drills through the perimeter and anchors a diaphragm wall with the surrounding subterranean soil. In this technique, soil is reinforced with slender elements such as reinforcing bars, which are called nails. These reinforcing bars are installed into rows of holes that are bored into the soil, and usually cement grout is injected under high pressure. Wedge plates provide added stability and secure the nail ends or wire rods reinforced with the cement grouting.
Thank you, Patient, for that presentation. This the diaphragm wall system we introduced first time to the Sri Lanka by Access Engineering. So next, this is the good example of the customization of piling and obtaining competitive advantage. This is good example of value engineering concept what we have done. Generally, the commercially available pile diameters in the market is the diameter 800. This is a bit technical, but I will explain in the simple language. The diameter is 800 millimeter, 1000, 1200, 1500. We checked this the cross-sectional area of these the pile diameters. You can see the 1000 to 1200 diameter. The cross-sectional area increment is 40%. But 1200 to 1500 diameter cross-sectional area is around 60%. So we need to pay for cross-sectional area increment. You can see the load carrying capacity of the 1200 pile is 8,000 kilonewtons, the unit of the load carrying capacity, and the 1500 pile is 12,000. If we have the load of say 8,500, we need to use the 1500 diameter pile, but it is the underutilization of 1500 pile, but we need to pay 60% more than the 1200 pile. So what we done on this is we introduced 1350 diameter pile. It's around 30% area increment of 1200 pile. Load carrying capacity is 10,000. So then 8,500, 9,000, 9,500, 10,000 in that range load, we could use the 1350 pile. And then we checked what are the cost difference between this 1350 to 1500 pile for a around 20 meter long pile. So we found that around 400,000 Sri Lankan rupees can be saved by doing this kind of modification. But the thing is, we didn't have the tool to do the 1350 pile. We imported this piling machine from the Bauer, the Germany. So we inquire whether they can do the 1350 pile diameter tool, but they gave us 1330 diameter pile in year 2020 at the cost of 8.4 million Sri Lankan rupee, which is 38,000 euros. In year 2020, we had issue with the COVID and as well as the financial downturn. We had very, the forex issue in the country. So therefore, then we checked whether it is possible to do this tool in-house, in our access workshop, whether we will be able to do this. And we found that with our the mechanical engineers, and found that we can manufacture in our workshop at the cost of 1.5 million. So at least we need 2 tools to do the piling for the larger project. So then we manufactured, instead of 16.8 million, we manufactured the tool at the cost of 3 million. So we saved doing the tool manufacturing as well as the cost saving and the material saving. And we employed this the 1350 pile for two project of the Access 2 project, and we saved 50 million only from this the value engineering concept. This is a good example what we have done the value engineering. Next, I would like to discuss about the horizontal directional drilling machines introduction of first time to the Sri Lanka. You know that in Sri Lanka, all the roads are asphalt, all the asphalt and all the things finalized and finished in the roads. Then all the service provider come in to the picture and dig everywhere and the road. Again, we need to do everything on the road surface. So then we checked whether any possibility to do the underground ducting without open excavation. So in year 2008, we secured the project from the Dialog Network Private Limited to lay the Dialog. This is called the fiber optic cable to Matara to the Wadduwa. So we introduced this concept, the horizontal directional drilling machine without open excavation of the road crossing. We introduced this concept and we performed that. And subsequently in this previous project, we did it with the 100 and 150 millimeter diameter, but subsequently we observed that this thing can be done for bigger pipe and 500 and 1000 millimeter diameter pipe, the pipes. So we introduced this concept to another project, the Hamilton Canal Crossing project for the Superdhanavi hydropower, the Superdhanavi, the diesel power plant project, to take the water from the sea across the Hamilton Canal. So we introduced this concept and we saved a lot amount of money and saved the environment and every other the environmental issues as well as the cost, very less cost we perform this construction. So there is another video here. I think it's better to play this video through there, and I will escape from here you to play that another video. Please enjoy a small video.
Furthering our investments in the logistics sector, Access Engineering invested in the design and construction of EGF2, a world-class distribution facility built to the exacting standards of Michelin International, the world's largest tyre manufacturer.
Next one.
This facility, which is situated on 30...
Throughout the developmental phase of the Sobadanavi hydropower plant, the greatest challenge to develop a seawater intake mechanism for the turbine cooling system for hydropower plant, necessitating the crossing of the Hamilton Canal in the Elaconda area. Accepting this challenge, Access Engineering plc introduced the horizontal directional drilling, HDD method, a value engineering technique pioneered by Access in Sri Lanka. This solution aimed to traverse the Hamilton Canal beneath its bed without disrupting or causing harm to the prevailing environmental conditions or the local community. Within the scope of this project, we successfully installed 2 SDR 13.6 high-density polyethylene HDPE pipes, each measuring 500 millimeters in diameter and spanning a length of 85 meters across the canal. Drawing upon the expertise and experience of our team, we successfully delivered the project to our client within a limited time frame.
Thank you for your patience for that video. And this project completed in year 2022. So now I would like to go to my main topic, the value engineering through local adaptation of expressway project. So not only the expressway project, any project, there are 4 phases to carry it out. One is pre-planning stage, second is during planning stage, third is during detailed design stage and during execution stage. So under each of these stages, we can do the value engineering and reduce the cost of the project. So during the pre-planning stage, what we can do, this is basically in the Sri Lankan context, client and client's engineer's responsibility, but I would like to give some overview of this, the pre-planning stage, what we can do. Whether we need to first, whether it is necessary to do the highway. We have seen in some highways in Sri Lankan context, there are very less amount of vehicles are passing through those the stretches. But if we can improve some other road network related to these stretches, we could be able to avoid this kind of highways. But you have seen that Kadawatha to Nittambu area, Kadawatha to Mirigama area, we need, definitely we need the highway, but it is still not happening. So therefore, evaluation of the traffic volume and demand and decision need to be taken whether it's necessary to do the highway. And the third one is the evaluation of the alternative route and improvement of them, whether we can avoid the highways requirement. And fourth one is the proposed most suitable path to have the expressway. And there can be several paths, I mean, there's several alignments, but we need to select the most suitable alignment to do the highways. So that is the pre-planning stage. During planning stage, that is also the client and client's engineer the responsibility. The first one is accurate assessment of the design inputs. Because design inputs, we are taking the design inputs from the existing condition, but we need to accurately assess these inputs. And we need to select, simplify alignment and geometry. Third one is the reduce the unnecessary structures. So we can select the road alignment such a way that it's reduce the unnecessary structures. The fourth one is standardized designs elements. So we can use the kind of the pre-stress element, kind of the culverts, kind of things to reduce the cost. And optimize land acquisition and explore public-private partnership. Last 2 items are very important because the land acquisition is the most important part of the highway project because that is the very big cost involving in this. And also exploring public-private partnership also important because the private sector will think about every time think about the return on investment. So therefore, it's very important to see these 2 items, last 2 items, when we are carrying out the expressway. The third one is during detailed design stage. This is actually the contractor responsibility. Generally, it is come to us as a contractor. There are few way of reducing the cost during the detailed design stage. Design concept change and use of precast, pre-stress, prefabricated elements, and use of geosynthetic materials and preloading and other methodologies are there to reduce the cost, 2-week ground improvement, and use of the customized element sizes such as pile diameters, beam sections to minimize the cost. As I explained in the pile diameter optimization and the customization, we can reduce the cost. And the other one is the design for durability. We can do the durable designs with very sustainable material, and we can reduce the cost from that as well. During execution stage, this is, I will give some pictures to you to give some understanding of this, how we have done the optimization and how we have reduced the cost in our Central Expressway project. The first one is the optimal use of land. So we can optimally use the land without the using additional land to do the construction. I will show with pictures how we have done it in the Central Expressway. Use of efficient construction technology and methods. We can, of course, use the, like I explained, like kind of horizontal directional drilling, and without having the open trenches, and maximum use of prefabricated the elements kind of thing. So then employing modern technology like LiDAR data survey, kind of the BIM integration, GPS methodologies, so we can use those technologies to reduce the cost. I will show that example in our project what we have done. Then change proposed construction methods using the sustainable materials. Use of mass earth retaining walls instead of conventional the retaining wall system. You know that the Kohuvela flyover, we have done this kind of mass earth retaining system without doing the conventional retaining wall system. It saved a lot cost to the project. So this is what we have done in the Central Expressway. The use of limited space in main trays for precasting yards of 415 number of 30-meter girder. We had to do the 415 number of 30-meter long girders for Central Expressway. So we used the highway. I mean, we didn't use extra spaces, the additional spaces. The highways what we have built itself used to construct fabricate this precast beams, and we stock the beam on top of others to minimize the land usage. You can see some pictures of what we have done, the limitation of the limit of the land usage. So on the other hand, we have manufactured the kind of the beam transportation the machines. So in order to minimize the crane machine usage, because if we cast the beams outside of the stretch, then we need to use bigger crane to the lift and place the beams in place. But in this condition, we manufacture this kind of the transporter machines, and we could be able to reduce the cost of the handling cost, and also the risk for the toppling the beam and damage to the beam is also very less by doing this methodology. So we you can see some beam launching mechanism, and as well as the conventional method of the testing of the pile is the general load, the putting the load on top of the piles, but we have introduced kind of ground anchors, and without using much machineries, we have done the pile testing like this way. So I'll show another video presentation you to give how we have done in the Central Expressway project to you to get some understanding of how we have done it. This is same stretch we have used to cast the beams without using additional extra spaces. So you can see big rock excavation in this area. If we initially checked our, in the initial design, the data checked properly, then we could have reduced this kind of rock excavation. This is around 45-meter rock excavation. This stretch is called CP31M package, the Kurunagal to Galagidara stretch. This is ongoing project. This stretch is going on. So I think because my time is over, so I would like to go to conclusion part. So can you stop this and yeah, I would like to conclude my presentation like this way. The value engineering is a critical aspect to today's context, considering the resource scarcity and the growing emphasis in sustainability. So exploring and adapting the latest global best practices while customizing them to the local conditions can significantly reduce the cost, save the time, and improve efficiency and enhance the quality and constructability of a project. The use of modular construction, construction concept and standardization tailored to the local condition is an effective way to reduce the cost and expedite the project completion. Of course, evaluating the alternative options and conducting the cost comparison can greatly contribute to the minimizing the both cost and the duration of the project. Conducting the post-project analysis, this is most important part. Post-project analysis and lessons learned will serve as valuable resources for future project. Integrating building information modeling and latest technology will enable efficient and project execution, minimize the rework and modification, and ensuring smooth coordination among all stakeholders. So this is the conclusion of my presentation. Thank you very much for your patience for this presentation. Thank you.
Thank you, Engineer Silva. We will now have our final Q&A session led by my colleague, Anushka.
Yeah, thank you, Subi. So let's dive right into the Q&A because we are a little tight on time. I think we went over the limit we have. If anyone has a question, I'll open it to the floor first. Yes, Mr. Mustafa. Could the mic be handed over to Sir Mustafa, please? Thank you.
I think there is a construction consortium that built phase 2 of the Central Expressway who has recently written a letter showing approximation between the cost difference of tendered projects versus unsolicited projects. There's a large difference. Of course, the terrain cannot be compared. So I'm assuming that that's the cost of corruption. But if you look at tender projects and if you look at the know-how and technology frontier that we operate in Sri Lanka, and you look at the best practices, how far are we from best practices?
Yeah, actually, when we are considering the construction practices, it's we are far behind. Actually, it's we need to improve much in our construction practice because now this what I showed in the presentation, there are a lot of the global best practices rather than what we are practicing in Sri Lankan context. There are way of reducing the cost and optimization as well as the minimizing the cost and resources. So we need to adapt all these kind of thing. What I have shown here is kind of example, but there are a lot of these kind of things we can explore for our the construction industry, and we need to adapt all this situation to the Sri Lankan context as well.
So if you take what you all learned from Central Express Phase 2 and were applying it to Phase 1, which is yet with the Chinese contract, and I believe that letter said that to re-tender that project and
Yes.
give an opportunity for you all to bid.
Yeah.
If it was awarded, how long do you think it will take a similar local consortium to build Phase 1?
You mean Kadawatha to Mirigama part?
Yes.
Yes. So in this part, the Mirigama, this Kurunagala to Galagidara part, actually it's a bit the difficult part. You showed it in this the rock excavation. A lot of construction aspects are there in this. But in order to do the Kadawatha to Mirigama part, it's quite straightforward. So I think 5 of the local contractors consortium is there. So I can think within within 3 years period we will be able to complete this the stretch, collecting all this. By consortium, all these contractors.
My final question is that if you look at, we talked about productivity gaps across industries in the earlier talks about the long tail. Now, your company perhaps is in the frontier of productivity in a local context. If you take the Sri Lankan average, are most of the construction firms significantly behind you?
Generally, the access we are trying to get most of the global the best practices to the Sri Lankan condition, and we try to adapt in the local condition. But I think all other the companies it's better to try out this kind of the new technology kind of thing to get into the Sri Lankan condition and do the betterment for the construction industry. So I believe it's there is a gap we need to fill in this situation.
Thank you, Engineer Silva. Engineer Silva, there's another question from our Zoom audience. So this is in relation to the brain drain in Sri Lanka and how a lot of educated people are leaving, including engineers. So what are the initiatives that are being taken to ensure that there are sufficient skilled labor available for projects on infrastructure?
Actually, this is the burning issue in Sri Lankan condition, today's context. So there are the non-people to me also, the skilled people, as well as the engineers, my batchmate as well, around after this COVID and this economic downturn situation. As per my mind, around 10 engineers migrated to the in my batch also into the UK and Australia. So therefore, the lack of the experienced engineers in the country is also one aspect. But the today's context is rather than doing this construction kind of thing, we need to, I think government need to think about how to drive the country for, the day-to-day activities and other things with the other aspect. But it time to come, construction should not be stopped. Actually, with the development for the country, the construction should be there. Then therefore, if this the projects coming into next, during next few months or during this year, we have big gap of the qualified people to do. How to we get done this work of the construction sector? So there are a lot of big gap, as well as the train engineers passing out from the universities also, they don't have much opportunities to train as well as to get the job. So in the construction sector, I personally know there are several other fields they are moving with the computer science as well as some other sectors they are moving. So therefore, that is actually the country requirement. If this kind of big boom comes in the future, then sometime we may need to hire the professionals from the other countries.
Thank you, Engineer Silva. Another question, yes. Could we have the mic to the front, to our madam in the front, please? Yep.
Thank you. My question is, after Sri Lanka has this free education, we send all the kids through schooling, free university, most of us get it, and then at the end, we go and serve another country. I think the country should put a barrier there. If you're educated in Sri Lanka, if you want to leave, you have to be penalized. Because this country should have the brains of this country retained in this country. And this is something I think the country as a whole should work towards, retaining the brains of the country, and if they leave, they should be given a hefty fine. Sorry to say that.
Yeah, actually, that is a good point. To answer that question, yes, of course, there should be some regulations like other countries. If they have taken this kind of course, we also have taken the free education in the government universities and government schools. So therefore, at least minimum period they need to work to the country, and they need to pay back whatever their responsibilities to the country. That should be there. There should be some kind of law enforcement kind of thing, because I have seen in the university kind of scholarship, when they are taking the scholarship only, they are having some bonds or kind of thing in the universities, but not in once we passed out from the universities, we can do anything. We can go to any country and we can work. But yes, of course, as you said, totally agreed. We need to have some kind of payback methodologies to the countries, what we have taken from the country.
Definitely. Thank you so much, Engineer Silva. Maybe we can squeeze one more question in from the Slido. So this is on the production, material production. So how can Sri Lanka further develop its material production capabilities to support the construction of highways in a cheaper and a more sustainable way? If we could have a quick answer to that, Engineer Silva, because we are running out of time.
Yeah, so actually, as I explained, the resources are very limited. So we need to think about the productively way of use of those materials. So that is the concept we need to practice, and also we need to balance when we are doing the construction, we need to balance the cut and fill kind of thing, the rock, the break from some location, we need to use those the same material to some other places kind of thing. So therefore, in that kind of situation, we need to do.
Okay, thank you, Engineer Silva. I think that will be the end of our Q&A. It's over to Subi. Thank you, Subi.
Thank you.
Thank you again, Engineer Silva, for your enlightening insights on value engineering in infrastructure. And with that, we come to a close of the Ignite Growth Economic Conference. Today's sessions have been rich with insights on how productivity can drive sustainable growth across sectors, offering us a roadmap to a brighter economic future. Over the past 2 days, we've been inspired, challenged, and empowered by the incredible depths of knowledge shared by our speakers and experts. But the true measure of this conference's success won't lie in the ideas we've heard or the discussions we've had. It will come from how we take these ideas and apply them in the real world. The conversations we've engaged in are not just theoretical, they are a call to action. They urge us to think differently, to innovate boldly, and to collaborate in turning Sri Lanka's immense potential into a thriving reality. As we conclude, I encourage each of you to take these ideas beyond the walls of this conference. Share them with your communities, your organizations, and your networks. Together, let's move forward with the conviction that Sri Lanka can and will build a prosperous future, but only if we act with purpose, resolve, and deep commitment to driving progress in every corner of our society. On behalf of Advocata, I would like to express my heartfelt gratitude to all our speakers, participants, and media personnel for making this conference a success. Let's continue the journey of transformation together. We hope and leave you with valuable insights and will help shape the future of Sri Lanka's economy. Hope you all have a wonderful evening, and let's keep the spirit of innovation and collaboration alive as we work together to transform ideas into action. Goodbye and have a lovely evening.